A differential equation is an expression of dy over dx in terms of x and y. For example, dy over dx equals 2x plus y. dy over dx equals xy. dy over dx equals x over y. dy over dx equals x sine y. These are all differential equations. In this class, we'll learn how to solve separable differential equations. A separable differential equations can be written as f of y dy equals g of x dx. One side is all about y, and the other side is all about x. That's why it's called separable. Now let's look at the above four differential equations one by one. Dy over dx is 2x plus y. It can't be written in the above format. So it's not separable. Dy over dx equals xy. If we divide y and multiply dx on both sides, this becomes 1 over y dy equals x dx. The left side is all y and the right side is all x. So it's separable. Dy over dx equals x over y. This can be written as y dy equals x dx. So it's separable. Dy over dx equals x sine y. This can be written as 1 over sine y dy equals x dx. So it's separable. Now let's learn how to solve separable differential equations. Dy over dx is xy. We can write it into 1 over y dy equals x dx. Let's put integral sign on both sides. And integrate both sides. The integral of 1 over y dy is ln y. The integral of x over dx is half x squared. And we need to plus c on one end. So ln y equals half x squared plus c. Therefore, y equals e to half x squared plus c. This is the general solution. If an initial condition is given, you can find a particular solution. For example, if y0 is e, we can put the values in the general solution and find c. When x is 0, y is e. So e equals e to c. Therefore c equals 1. And the solution is y equals e to half x squared plus 1. This is a particular solution. With a different initial condition, the c value may be different and there may be another particular solution. Now let's look at another example. Cosine y dy over dx equals 2x. It can be written as cosine y dy equals 2x dx. Integrate both sides. We get sine y equals x squared plus c. So y equals inverse sine of x squared plus c. If the question doesn't ask you to express y in terms of x, you can leave it in the form after integration. dn over dt is n times 1800 minus n over 3600. It is given that n is 300 when t is 0. Find an expression of n in terms of t. First, let's separate n and t. Turn it into the integral of 3600 over n times 1800 minus n dn is the integral of dt. For the left side, we can break it into partial fractions. Let it equal a over n plus b over 1800 minus n. Combine them, we get a times 1800 minus n plus bn over n times 1800 minus n. So a times 1800 minus n plus bn equals 3600. Let n equal 0. We get a as 2. Let n equal 1800, we get b as 2. So it becomes, the integral of 2 over n plus 2 over 1800 minus n dn is the integral of dt. The integral of 2 over n is 2 ln n. The integral of 2 over 1800 minus n is minus 2 ln 1800 minus n. The right side is t plus c. Put in the initial condition, we get 2 ln 300 minus 2 ln 1500 equals c. So c is 2 ln 300 over 1500, which is 2 ln 1/5, which is minus 2 ln 5. So the equation is 2 ln n minus 2 ln 1800 minus n equals t minus 2 ln 5. Divide 2 on both sides and move ln 1800 minus n to the right side, we get, ln n is ln 1800 minus n plus half t minus ln 5. Raise both sides to the power of e. It becomes, n equals 1800 minus n times e to half d over 5. Multiply 5 on both sides and break the brackets. It becomes, 5n equals 1800 e to half t minus n e to half t. So n is 1800 e to half d over 5 plus e to half t. In this class, we learned solve separable differential equations. Separate two variables on different sides. We integrate both sides to get a general solution. We can find a particular solution given an initial condition.